Hi, what's up? Thank you for coming and watching the video. Today we're going to be talking about Riemann sums. So first let me draw out a function real quick. Say it's like, well, first let's draw our coordinate axes. Yeah, that looks fine. I'll move that over here because I don't really need too much of it. Just the kind of rightwards part. All right, so say we have a function like that. And we want to integrate it. Or you know what, that's not such a great function. Let's say it's like we want to integrate it and we don't really know how. We don't really have an we don't really know what's going on. We don't really we're not really thinking too much about this. Let's just think about it like this. What if I wanted to make rectangles? Well, first let's start it. We want to take the integral from like 0 to I don't know, whatever. 5. All right, let's call this 5. 5 sounds good. All right. This is 0. We know that. Anyway, this should be about 3, or should it? I don't know. What is this? 1, 2, 3, 4. You know what? That's not very accurate. This might have to be 2, 3, 4. No, that's not very accurate either. That's gonna be 2.5. This is gonna be 1.25. This is gonna be 3.75. That's pretty accurate. All right, so if you wanted to make rectangles into it, it looks something like that. You can go up here. You can go like up to here. Oh, that was a bad line. Let's try that again. And then up to here. All right, so these are all rectangles, and I'll shade them in kind of like that. Then we just have to do this area out, right? So let's call this line f of x. This would be LRAM, the left Riemann sum, because we're starting on the left side, and then we're going across like that. Yeah, LRAM with 4. We don't say rectangles because that makes too much sense. So instead we're going to say equal subintervals. All right, and that's that. That's LRAM. Now what if I wanted to do RRAM? Then I would have to delete all this. Sad, I know. Doot, 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 doot. Delete the left. Okay. We go up here. Probably start on the right side and go across. Yeah, that looks about right. We can go up there, cross. This is just RAM, you know, right Riemann sum approximation. All right, makes sense. This over here, this would just be nothing. This would be 0. You wouldn't even get anything for that. Right, and then we'd shade in this kind of stuff over here. Then you can calculate the area of those rectangles, and that'd be that. So we RAM. And then what if we wanted to do something really wacko? What if instead of rectangles we wanted to do something wacko like, I don't know, like a trapezoid? And that would be really weird. But you know what? It's a thing. You wouldn't think it, but it actually is a thing. So then what you would say is you'd go and make some lines. You'd go like, all right, well, that's a straight line. It's going from 1 right to there. Then we're going down. Then here, we're going to go from here to here. Then we're going to come back down. Then we're going to go over to here. And we're going to go right across. Then we're going to come back down. And here, this is basically a straight line, so we'll just follow along with it. Anyway, so for this, we're going to just shade in this kind of stuff. And that'll be TRAM. Now for RRAM and LRAM, it's basically just going to be multiplying base times height, right? Base times height. But for trapezoids, well, oh, what the hell is a trapezoid? I don't even know how to take the area of that. Basically, what you're going to be doing is you're going to be averaging the top and the bottom bases. So let's just draw like a trapezoid here. Maybe OneNote has a trapezoid ready for us, and they don't. Wow, that kind of sucks. Whatever. All right. You know what? OneNote, I don't need your help. I'll just draw a trapezoid on my own. So this is a trapezoid. It's got a flat bottom, flat side over here because this is where it's going to hit the x-axis. Anyway, so we've got this side over here, kind of being a little bit wacko. So what we're going to do, because since this side and this side aren't the same, is we're actually just going to take the average of those, right? Let's call this B1, B2. And the area is going to be B1 plus B2 over 2 times H. And that's that. Or this is H, of course. So then you're just going to take like that at that x interval, like x1 minus x2 times like, well, let's just say f of x1 minus f of x2 times h, which is just, oh, we already did that, never mind. That's going to be times 1/2. All right, there you go. Those are 3 different kinds of Riemann sums. I'm not going to do midpoint because that's kind of stupid. And yeah, all right, thank you for watching. I hope you liked it, hope you learned something, and see you next time.